so vital to understand the following lecture.
دكتورة اكو بالخيارات تقدرين تعملين ليكتشر مود حتى كذا يصير ميوت لان الطلاب ما يعملون ميوت.
نعم
دكتورة بالخيارات عندك دكتورة على اللابتوب او لا دكتورة انت عندك موبايل لابتوب طلاب بس اللي ما عمل ميوت خليه يعمل ميوت حتى لا تصدق سيرين. كمل دكتور.
سوري عبد الرحمن بس مع شهادتكم لازم اسمع اللابتوب يكون اوضح فعشان التعليق.
لا دكتور ها هي بس على مكان طلاب ما كان هذا هو عامل زي دكتور.
اوكي هسه نبدأ.
نعم دكتور.
So again, understanding of embryology is so vital to understand the following lecture about abnormal development of the female genital tract. I expect you listen to the recorded lecture, and we will concentrate today on the important point. As we said, the understanding of the development of and anatomy of female genital tract is important in the gynecology practice, and especially when we consider the abnormal development. Important point that you have to keep always in mind that both urinary and genital system develop from a common mesodermal ridge. So it is expected that abnormality of one of these systems may be associated with abnormality of the other system. And when you encounter an certain abnormality, not all abnormality, of the female genital tract, especially those who are related to Mullerian development, you have to consider associated abnormality of the urinary system. As you all know, that following fertilization, the normal zygote have a 46 chromosome or 23 set of chromosomes. 22 of them are autosome and one is a 6 chromosome. And this one set of 6 chromosomes can be either XX or XY. This is what is normally occur. If this zygote has the 6 chromosome of XX, it will develop into a female embryo. While if it is XY, it will develop into a male embryo. However, not only the 6 chromosome which determine the sex of the developing embryo, as we will talk in the following slide. But one of the factors that determine the sex of the embryo is the 6 chromosome. If it is XX, it will develop. If it is XY, it will develop as male. We all know this basic fact. Why this? Why the difference in this Y chromosome? The presence of this Y chromosome guides the development of the embryo into male, while it is absence, it guides its development into female. Although it is really, it is not only the absence of Y chromosome. As a general principle, or what was previously known, that is the presence of Y chromosome guide the embryo to develop into a male, and it is absence guide the embryo to develop as a female, although female development now is considered to require 2 active X chromosome, and there may be certain gene that influence the development of female embryo. Again, we return to Y chromosome and how it can play this vital role in development of the embryo. There is a specific region in this Y chromosome called SRYG, or sex determining region on Y chromosome. It is located on short arm of the Y chromosome. The protein product of this gene is considered a transcription factor, and it initiates a cascade of downstream genes that determine the fate of primordia of the sexual organ. This gene trigger, in conclusion, this gene trigger testis formation of the from the indifferent gonad. And when it trigger the indifferent gonad to develop into a testis, it will produce two important substances that has more than one role in developing of the genital and sexual organ of the embryo that we will talk about in the next few slides. So, a presence of this gene in the short arm of the Y chromosome, which is called SRY gene, will influence the development of the indifferent gonad into a testis. And later on, a sequence of changes will occur, which influence the development of the embryo. And if there is a mutation of this SRY gene, there will be a pure gonadal dysgenesis or hermaphroditism. And although genetic sex is determined at time of fertilization, the zygote either have XX chromosome or XY chromosome, and the genetic sex is determined at time of fertilization. The gonad don't acquire the male or female characteristic until the 7th week of development. Before that, there is no difference in the gonad, or it is in the indifferent stage. In the indifferent stage, the embryo will not be distinguished between a male or female. Both those who carry XY or X chromosome has a gonad, has the indifferent stage, which in which there is no difference between the gonad, between the internal genital organ, which composed of a two set of genital duct, and an external genitalia, which are similar in both sexes. So the sexual development of an individual is determined by or the sexual differentiation or determination of individual is determined by 3 types of sex, which is the genetic sex, which is determined at fertilization as XX or XY, gonadal sex, which is represented later on by the ovary or testis, and the phenotypic sex, which involves both the internal and external genital organs. Both genetic sex, of course, it is determined at time of fertilization, and it is different between male and female. Those with in female it is an XX, and in male it is XY. Gonadal sex and phenotypic sex pass through two different stages or 2 different phases: the undifferentiated phase and then the differentiated phase. In the indifferentiated stage, it is indistinguishable between male and female, while in the different stage you can differentiate the gonad or the internal and external genital organ between male and female. So the second factor that can determine the sex of individual is by the gonadal sex, represented by the gonad. And again, we said that the gonad does not cannot be distinguishable until the 7th week of development. To start with, it appears as a gonadal ridge, which appear as a pair of longitudinal ridge lie ventromedial to the mesonephric kidney. And it is similar on both male and female. This appears during the 4th week of embryonic life and later become differentiated after about the 7th week. The undifferentiated gonad has the potential to become either a testis or an ovary, and hence it is termed bipotential because it can be developed into one of two gonads, and the chromosomal component of the zygote determine whether the gonad become a testis or an ovary. This is the gonadal ridge. It appears as a longitudinal ridge pair to ridge lie medial ventromedial to the mesonephric duct or mesonephros. Important point that in the development of this gonad, it is not only the presence of this gonadal ridge, but it should receive the germ cell that migrate to it from the yolk sac. So the presence of gonadal ridge cannot be differentiated into a proper gonad unless it receives, which primarily develop in the wall of the yolk sac and migrate to the gonad and migrate to the gonadal ridge. If migration fails, gonad don't develop, and this migration occur around the 6th week of development. عفوا طلاب الصوت واضح؟ أكو مشكلة؟
نعم دكتورة واضح. دكتورة واضح الصوت.
عفوا طلاب الصوت واضح؟
نعم دكتورة واضح الصوت.
So again, for the proper development of gonad, this gonad should receive the germ cell which migrate to it from the wall of the yolk sac along the posterior, along the hindgut mesentery. This is the pathway for migration of the germ cell. It comes from the yolk sac and migrate along the mesentery of the hindgut to reach to the gonadal ridge. This occurs about 5 to 6 weeks of development, and if this process fails to occur, the gonad will not develop. And this is one of the theory behind the Turner syndrome. There is a gonad, but there is no germ cell in it. Gonadal ridge later on, gonadal ridge continue to proliferate by proliferation of the colonic epithelium and condensation of the underlying mesenchyme during the stage of differentiation. Colonic epithelium proliferate and penetrate the underlying mesenchyme from forming a primitive silk spore, and the gonad now possesses an outer cortex and inner medulla. This is in the indifferent stage. So after migration of the germ cell, the gonad proliferate, develop by proliferation to form and outer cortex and inner medulla, and this similar to both male and female in the different stage. Later in the differentiated stage, we will see that the cortex become prominent in the ovary, while the medulla degenerate or regress, while in the male the opposite is true. There is a proliferation of the medullary component, while the cortex degenerate. So this is in the indifferent stage. It is impossible to differentiate between male and female gonad, and hence it is now at the indifferent stage. Both has a germ cell, a sex cord, and a mesenchymal stroma. The sex cord will later be either granular cell in the ovary or sertoli cell in the testes, and the mesenchymal stroma will have a potential theca or Leydig cell. In the indifferent stage, as we said, the gonad is not distinguished. It has an inner medulla and outer cortex. With the influence of the Y chromosome, the indifferent gonad will be differentiated into either a testis, where the medullary cord develops and cortical cord regress, and there will be a tunica albuginea. While the absence of Y chromosome, and again there is of course certain factors that influence the development of the ovary. The medullary cord degenerate, the cortical cord develop and become prominent, and there is no tunica albuginea. And this diagram represents how this differentiation occurs. In the testis there is prominent medulla, while in the ovary there is prominent cortical cord. This is about the gonad. Now we will talk about the internal genital system. And again, what I will say in this next few slides is important to understand the following lecture about abnormality. The internal genital system in the indifferent stage is constituted of a two pair of duct system, both in male and female, which are the genital ducts. These two ducts are the paramesonephric duct or Mullerian duct, and lateral to it is the mesonephric or Wolffian duct. Both male and female in the indifferent stage, the internal genital system comprise of two duct systems, the mesonephric or Wolffian and paramesonephric duct. While in the differentiated stage, in the male, the mesonephric duct will become prominent, while the paramesonephric duct degenerate, and the opposite occur in the female. The paramesonephric duct continue to grow and proliferate and differentiate to form the female genital organ, while the mesonephric duct degenerate apart from certain remnants. What influences this differentiation of the genital duct? Again, it is by the developing gonad. The determination, this proliferation of certain duct and degeneration of certain the other duct in both sex is influenced by the developing gonad. And the main gonad that influences this differentiation of the genital duct is the testis. The presence of the substance that is produced by the testis, or the absence of this substance which is produced by the testis, influence the development of this genital duct. How? If we have, if the gonad is testis, and differentiate properly, it will produce two important substances, which is the Mullerian inhibitory factor and the testosterone. Mullerian inhibitory factor is produced by the Sertoli cell, while the testosterone is produced by the Leydig cell. We'll talk first about Mullerian inhibitory factor. This is a substance produced by a Sertoli cell. It is a glycoprotein. From its name, Mullerian inhibiting factor. So it inhibits. Inhibit what? Inhibit the Mullerian duct. So when this substance is present, Mullerian inhibitory factor, there will be a regression of the Mullerian or paramesonephric duct. So this duct will disappear. And it acts locally on each testis. So those produced from the right testis, it will act on the right Mullerian duct. And those produced from the left testis, it will act on the left Mullerian duct. So if there is agenesis of single testis, certain abnormality, there may be unilateral unilateral proliferation of the Mullerian duct because of the absence of this substance. So, and this substance is produced by the of the testis. We expect in the male there will be a degeneration of Mullerian duct. While absence of this substance in female due to absence of the testis and the gonad is an ovary will help the proliferation and differentiation of the Mullerian duct to develop the internal female genital organ. Mullerian duct is sensitive to Mullerian inhibitory factor only during the first 8 weeks of development. So if there is any abnormality during this period of development, even if this substance is present later, it will not help the regression of the Mullerian duct. The other important substance that influence the differentiation of the genital duct is the testosterone, which is produced from the Leydig cell from the 8th week of development to influence the development of the Wolffian duct, and also it affects the differentiation of the external genitalia. The effect of testosterone on Wolffian duct is direct. It means it does not need conversion to other substances. If testosterone is present, produced by the Leydig cell of the developing gonad, which should be if it is a testis and develop normally and have a normal Leydig cell, this Leydig cell produces testosterone. This can influence the development, the differentiation of the Wolffian duct into a male internal system represented by the tubule and the vas deferens. Also, this testosterone, which is produced by the Leydig cell, can affect the development of the, or differentiation of the external genitalia. But for this, it requires the conversion into a more active substance, the dihydrotestosterone, by the enzyme 5-alpha reductase. If this conversion occurs and the enzyme is present, this dihydrotestosterone influences the masculinization of the external genitalia into male sexual organ. Why? If it is absent, or if the conversion does not occur, the external genitalia of that individual will develop into a female external genitalia. Is it clear? This is a summary of about what I said shortly. The differentiation of the genital organ is determined by the SRY gene product, which acts as a transcription factor that induces expression of downstream gene leading to production of Mullerian inhibitory substance and testosterone from the developing gonad, which develop as a testis. Mullerian inhibitory substance produced from receptor cell responsible for ipsilateral regulation of paramesonephric, while testosterone responsible for the development of mesonephric duct into male external genitalia. So again, in the indefinite stage, you can see it is not distinguishable, too much distinguishable between male and female. Both individual will have a two pair of genital duct. It is the mesonephric duct, and lateral to it is the paramesonephric duct. In the female, there is no testis, there is no Mullerian inhibitory factor, and there is no testosterone. So, as there is no testosterone, the mesonephric duct, mesonephric system or mesonephric duct degenerate. No testosterone, no Wolffian duct or mesonephric duct. In the other hand, there is no Mullerian inhibitory factor, so Mullerian duct continue to proliferate. This Mullerian duct will caudally the two Mullerian duct deviate more and more medial till it is swell of the opposite side. It diffuses and projects into the posterior of the urogenital sinus, forming the Mullerian tubercle, and the fused portion of Mullerian duct gives rise to the uterus cervix and fallopian tube. You can see this Mullerian duct come to pass medially until it is meet the other one in the from the other side. These two ducts should be fused, and later this wall between the two fused systems should be reabsorbed. At the distal part, it is used to form a Mullerian tubercle which join the urogenital sinus. So this two Mullerian duct will form the fallopian tube, which it is a proximal part open into the peritoneal cavity through the fimbria. It forms the uterus, the cervix, and upper part of the vagina. And we can see that the Wolffian duct in female regress apart from certain remnant remain as a remnant represented by the epiphoron, paraphoron, or Gartner cyst, this blue colored remnant. For the vagina, there may be some doubt about its development. In conclusion, it is developed from the fusion of the distal part of the Mullerian duct, which is the distal part of the Mullerian duct, which form a Mullerian tubercle. This project into the dorsal wall of the urogenital sinus. So the vagina form from the two elements, the Mullerian system and the urogenital sinus, which constitute to the major part of development, is in doubt, but it is thought that the major portion is formed by the urogenital sinus, and maybe a small part of the upper vagina come from a Mullerian component. To start with, the vagina is a solid, but it becomes canalized during the first month of development, and if this canalization does not develop, we may end with vaginal atresia. The vagina remains separate from the urogenital sinus by a thin plate, which is the hymen. This a thin layer of the by the hymen, which consists of epithelial lining of the sinus and a thin layer of vaginal cell. It develops a small opening during prenatal life. If this opening does not develop, we may end with interferate honey. You can see this diagram represents the development of the vagina. It forms from the first portion of the Mullerian duct, which forms the Mullerian tubercle, and this sinovaginal bulb to start with is, and you can see that now the recent theory that this sinovaginal bulb contribute to the major portion of the vagina, and to start with it is solid and later become canalized, and it is remains separated from the urogenital sinus by this tissue plane which forms the hymen. Remnant of the mesonephric system in the female, as we said, with the absence of testosterone, the mesonephric duct or Wolffian duct in female degenerate, but a remnant of a small part may remain. This is represented by the equiphoron, paraphoron, and Gardner duct cyst. The hydatid cyst of Morgagni is a remnant of the, or a small remnant of the Mullerian duct, which form a small cystic structure in the distal part of the fallopian tube, and this may be sometimes become large and enter in the differential diagnosis of the adnexial mass. So you can see this is the pathway of original Wolffian or mesonephric duct. This degenerates apart from some remnant, which is either the equiphoron, which is the proximal tubule of the mesonephron, the paraphoron, the distal tubule of the mesonephron, run along the fallopian tube and uterine wall, and the Gardner duct cyst, which is usually found along the side wall of the vagina. But while the hydatid of Morgagni, it represents a remnant or a distinction of the proximal part of the Mullerian duct, which appear as a cyst attached to the fimbrium, and this can be of a variable size. Lastly, the external genitalia. This is indistinguishable between the two sets until the 12th week of embryonic life, and again it is influenced. Its differentiation is influenced by the testosterone produced by the right cell. However, this testosterone needs to be converted into a more active substance, 5-hydrotestosterone, by the enzyme 5-alpha reductase to induce its effect. If this enzyme is deficient, or the receptor for the substance is absent, or testosterone from the start is not present, there will be no masculinization of the external genitalia, and it develops as a female, even if the sex of the embryo is XY, or even if there is a testis. In the indifferent stage, the external genitalia consists of two genital folds, two genital swelling, and midline anterior genital tubercle. This is in the indifferent stage, both male and female. We have a genital fold, a genital swelling, and genital tubercle. If there is testosterone, which properly converted to dihydrotestosterone, this will induce masculinization of the external genitalia into a male, where the genital tubercle form the glans penis, the genital fold form the penile urethra, and the genital swelling form the scrotum. In the female, the absence of this substance, the genital tubercle become the clitoris, which is equivalent to the glans penis. The genital fold form the labia minora, and the genital swelling form the labia majora, which is equivalent to the scrotum. As we said, that the effect of testosterone on the external genitalia require its conversion to the more active substance, dihydrotestosterone, by the enzyme alpha reductase, and this masculine the testis begin to secrete testosterone by 8 to 9 week of development. The masculinization of the genitalia observed about a week later, 10 weeks, and completed by 14 weeks. And this is the external genitalia in the female. The genital tubercle become the clitoris. The genital fold become the labia minora, and the genital swelling will become the labia majora. And this is again due to the absence of testosterone. Now the floor is open for any question. This is the summary. I think you go through by listening to the previous lecture, the recorded lecture. Now the floor is open for any query. طلاب
والله اللي سؤالي كويس عبد الرحمن
ويلكم. طبعا يعني ارحب بالاسئله، اي نقطه ما مفهومه ارجع اقول فيلم هاي المحاضرات ليش هو حتى المحاضرات القادمه. لا ما معقول يعني ما اعتقد.
تمام يعني هو
اوكي عشان انا اختبر يعني الفهم مالكم، understanding. Can you summarize the development of the genital duct in the both indifferent and different stage, undifferentiated and differentiated stage? What are the genital ducts? What are the name of the genital ducts that present in developing embryo? your interaction is disappointed. صوت ماما واضح لان انت ما صوتكم فربطت المايك يعني صراحه لان اذا اشيل المايك صوتكم ما يكون واضح. Then again, what are the type of genital duct that present in developing embryo? What are the genital duct that become prominent in female embryo?
دكتورة الموليريان ده
طلاب بتسمعون الأسئلة؟ زين أنا وين بكتب هاي المسجات عندي؟ زين سوري جيد. Okay. What are the main genital ducts that become prominent in the male embryo?
الميزونيفريك داكت دكتور.
Okay, fine. What does influence the development of mesonephric duct in male embryo?
العفو دكتورة، بس الصوت ما واضح يعني ما عاد نسمع السؤال.
مفهوم السؤال؟
نعم دكتورة. testosterone from the Leydig cell.
What does influence the differentiation? Truly, it's not the development or the differentiation or development of mesoreproduct in male embryo.
Testosterone دكتورة from the Leydig cell affect the differentiation of the Wolffian duct.
Doctoral gonads will not develop.
Okay, صح. وفران gonad will not develop, and this it may be a theory for about the pathogenicity of Turner syndrome. But even in male, if the germ cell does not migrate to the gonadal ridge, the gonad degenerates and disappears. Okay. What does influence the development of mesonephric duct in male embryo? What does influence the development of mesonephric duct in male embryo? I think this is a simple question. It is repeated many times in the lecture.
Testosterone دكتور.
Oh, it is the testosterone, and it can act directly without the need for conversion of dihydrotestosterone. Okay.
I get you again.
What does influence the differentiation of external genitalia?
Dihydrotestosterone active form. Dihydrotestosterone دكتورة.
Okay. If it's the dihydrotestosterone that will be converted from testosterone by fat either reductase. اللي عايز لي عايز لي ان رجع تنظف المايك. Again, I want to listen to your comment. More. اوكي بس اخير كومنت، يعني احنا حتى نحصل ميل اكسترنال جينيتاليا لازم اول شيء عندنا واي كروموسوم. هذا الواي كروموسوم حتى يكون عندنا جوناد ديفلوبينج جوناد تيستس، والتيستس تفرز تستوستيرون، وبعدها نحتاج الكونفرشن مع التستوستيرون الى دايهيدروتستوستيرون باي بارادكتيز. طبعا الدايهيدروتستوستيرون يحتاج ريسبتور، فاي خطوه راح يكون اكو ديفكت ما حنحصل الديفرنشيشن مع الاكسترنال جينيتاليا. Thank you for your listening and we will meet again in the next lecture. Thank you for your